Today's lesson, section 4.1b, we're talking about exponential functions. Here we have an application for exponential functions in the form of compound interest. So the formula for compound interest is going to be calculated by a of t equals the principal, p, times 1 plus r divided by n to the nt power. So a of t is the amount of money that you make after a certain amount of years of it being in this account. P is the principal or the starting amount. R is the interest rate per year. N is the number of times interest is compounded per year, so like calculated and then put back into your account. And then letter T is the number of years that your money's in this account. Okay, so for example 5, I want to find a sum of $2,000 is put into a IRA that earns 7% per year. Find the amount in the account after 10 years if interest compounds annually. So A is going to equal, let's use a different color here. So our T is going to be 10. That's going to equal 2,000, which is our principal, so our starting amount, times 1 plus our interest rate. So remember, interest rate, since it's 7%, we convert that to a decimal, which is 0.07. Annually compounds, so that's just once. So then 1 times the 10 power for time. Okay, so let's simplify this a little bit. So 2,000, 0.07 divided by 1 is 0.07, so plus 1 would be 1.07, and 1 times 10 is 10. So if I plug that into my calculator, I get $3,934.30. Okay. Now, one thing for your notes is that n has different values. So just so you know what numbers to plug in for n. If it's annually, then it's once a year. Semi-annually would be 2. Quarterly would be 4, monthly is 12, and daily is 365. Okay. Example 6 wants us to look at our formula a little bit differently. So they want us to find the annual percentage yield for an investment that earns interest at a rate of 4% per year and compounded quarterly. So here, what they're trying to ask you is, what is the percentage that you'll make in a year from your loan, or your savings account, or your CD or IRA, whatever you're investing in. Okay, so if T is 4%, T is 1, since we're talking about annually, R would be 4%, okay, or 0.04, and then N is 4, because it's quarterly. Now I can plug those in. It really doesn't matter the ending amount or the principal that I put in, because it should all balance, be the same no matter if I put $10,000 in or as opposed to 1. Even though I'm making a different amount of money, the percentage that I'm making is still going to be the same. So the proportion of money profited to the money I started with, it will be the same either way. So A of 1 equals P times 1 plus 0.04 divided by 4 to the 4 times 1 power. So let's simplify that a little bit. 0.04 divided by 4 is 0.01. So that gets me 1.01, and then 4 times 1 is 4. So let's make that one number. So if I took it to the 4th power, it would be 1.0406, and so on and so forth. Okay. So then now I want to find that percentage of annual or yield. Okay. So one thing to do is because you're kind of changing this into simple interest. Okay. Since it's only accruing interest once a year, that's kind of like a savings account. And so savings account is based on the formula of the amount times, or is equal to the principal times 1 plus your rate. So if you want to know your rate, you could set these two equal to each other because they're both equal to the amount of money you make after 1 year. So then P times 1 plus R is equal to P times 1.0406. So if I divide the principals away, so you don't need them, so then 1 plus R is equal to 1.0406. And then here I want to solve for R, so I subtract 1 to both sides. So that gets me 0.0406. So my percent for annual yield would be 4.06%. Okay? And so that'd been the answer. Okay? And then the last thing before we're done is that one thing to introduce 4.2 is we'll start talking about the letter or the number E. Okay, the number E is defined as the value that kind of goes along with our compound interest, if you see that it's similar. Okay, so 1 plus 1 divided by n to the n power. Okay, so E is a number that if you approach, or if n approaches or becomes very large, so when I plug in n as being like a billion or something, then we get really close to this number of 2.71828, and it continues on. It's kind of like pi. Another name for this is called Euler's number, and he's a mathematician that kind of discovered this number using certain ratios, and it kind of ends up being in kind of natural things as well. If you kind of search them, it might be a fun thing to look at. But we'll use this number with our natural exponential functions. So, like if we do exponential functions as e to the x instead of a to the x, those have some natural properties when you're looking at exponential functions for like bacteria and those kind of things. Okay, so have fun.